Okay, we're going to take a look at one more example on parametric equation. This question has got two parts. Let us solve the first part first, which is finding the gradient is the first part. Finding the gradient of the curve at the point 1, 1. Similar to the previous example, so I'm going to go through a little bit fast. What you want to do is to find dx dt first and then find dy dt, right? Alright, dx dt first and then you find dy dt, which I'm going to do very, very quickly. You should be able to do it. Alright, dx dt, I use quotient rule like that. Alright, quotient rule. Essentially, you want to differentiate the numerator, which is 1, and then times the denominator, and then differentiate the denominator multiplied by the numerator. Then you get something like that. Right, you get that. dy dt, again, you also use quotient rule. You apply it, I'm sure it's not difficult to get there. So what is dy dx? dy dx will just be dy dt divided by dx dt. So you take dy dt divided by dx dt, you simplify, alright, you should be able to get something like that. What do you want? You want to find the gradient at this point 1, 1. So, but you are not going to substitute x equals to 1 here, wrong. Right? Why? Because everything is in terms of t. Surely you also cannot assume that t equals to 1. No, because when x equals to 1, t may not be equals to 1. So what we want to do is to find the value of t at x equals to 1. Right? At x equals to 1, what is the value of t? So which means here, you substitute, let this, your x, this one be 1, you solve, you realize that actually at this point 1, 1, your t is actually 0. Only then we can substitute 0 in, right? Then you will get your dy dx equals to 1. So first part we are done. We have found the gradient of the curve at 1, 1 is actually 1. Okay, I repeat, you don't just assume x equals to 1 here. You cannot substitute. Okay? Alright. Next, let's deal with the second part of it. Right, this is for the second part. Alright. Let us take a look. You want to find the point where the tangent is parallel to y equals to 4x. When we say tangent is parallel to y equals to 4x, means the gradient of the tangent is actually 4. Right? It's actually 4. And recall in earlier part, recall in first part from here, actually we have done the hard differentiation. Your dy dx from your earlier part was 1 minus 2t whole thing square over 1 minus t whole thing square. Right, so we equate that to 4. Yes. Alright, then we try and solve. I cross multiply and then I expand, I get 1 minus 4t plus 4t square equals to 4, 1 minus 2t plus t square. Yes, I solve, I eventually, the 4t square goes, correct? The t square goes, I will get t equals to 3/4. Okay, not difficult to get 3 equals 3/4. Now, which means at that point t equals to 3/4, correct? Your dy dx is 4. Now, but what do they want? You want to find the point at that point. Meaning to say, I need to find the x coordinate. I substitute t equals to 3/4 into here. I get my x coordinate. I sub t equals 3/4 into this. I get my y coordinate. But don't stop there, because when you want to find a point, you are expressed in coordinates. So final answer must be in terms of coordinates. Alright, that's that. Thank you.